It all started with a big bang.
We are Team 7203 KNO3, third-year FTC team from Plant High School, Tampa, Florida.
During summer, we established the South Tampa Robotics Foundation and received a 501c3 nonprofit designation. We had several team meetings, decided on the team uniforms, marketing materials, and made necessary enhancements to the team's website.
We used every opportunity to give back to the community that has given so much to us. We shared our experiences and promoted the founding principles of FIRST and STEM at MakerCon, Roboticon, and Tampa Innovation Alliance, TEC. Through our participation in the Metropolitan Ministries Partnership Elementary School, we brought the power of STEM to the kids from the low-income families. It was incredibly rewarding to see the smiles on these kids' faces when they took turns driving our robot. We are always there to help other technology clubs. Whether we are mentoring local middle school robotics teams, our sister team Biohazardous, we are always strive to exemplify gracious professionalism.
We started with reviewing the scoring chart to determine our strategy for the game. Our goal was to identify the task that would give us the maximum amount of points in the least amount of time. Based on our vision of robot design elements, we've concluded that the middle goal was the most achievable. Another way to earn points was releasing the zip liners and parking the robot on the ramp during the endgame.
Our chassis was designed to reach the top of the ramp. However, we realized this would be impossible with the targeted ground clearance and time. We designed the chassis to drive over the first bar on the ramp and deposit in the mid-goal. Our robot's drivetrain is powered by 4 Andy Mark Never Rest motors for more strength and reliability. They're mounted outward to conserve space or components and drive the axles via chain, maintaining a 1-to-1 ratio, providing speed without compromising torque. We use a combination of Andy Mark Stealth and Tetrix Omni wheel.
Initially, we decided on a system that would collect game elements in a box set and then lift them up. We used the Tetrix racks on 12-inch bars with a simple spool that used fishing line. This system would take up the interior of our robot while on the rim stood another lifting neck. This was driven by a single pinion, racks along with string that would drive the system. After our first competition, we decided to simplify the design and use our hanging mechanism to collect and deposit game elements, as our original mech was very slow and inefficient. One of our static parts was actually the collector, which stayed at the front of the bot and used 21 motor and spearfish tubing, but the actual hopper was quite dynamic. From starting out of a simple box that had sliding doors to our present design of a hopper that can slide left and right upon an axis, and then tilt to deposit the game elements.
The robot software was written in Java. Due to the increased flexibility with the Java programming language, we created a very modular system for programming Atlas, which allows the same controlling code to be used for teleop and autonomous phases. Our autonomous program simply scores into the climber shelter with plans to improve accuracy using gyro and acceleration sensors for sensor fusion, course correction, and collision detection.
We held several fundraising events. The money raised helped us with team registration, competition fees, and paid for new parts. We raised awareness about FIRST and educated young aspiring engineers about the STEM programs. We are deeply grateful to our mentors and sponsors, Nestle Professional Beverage, Rockwell Collins, Raytheon, Academic Foundation of Plant High School.
We are a hardworking and fun-loving team. Our favorite team building events are Melted Down Day and the Escape Room Puzzle. KNO3 is always connected to the world through Facebook, the team website, First FTC blogs, and the Panther Press. We use Dropbox to share files, Skype and group messaging to communicate and exchange ideas.